What is up, dudes? All right, so today we're going to be taking some notes on how to verify trig identities, okay? And the main thing that you want, and I still, after 20 plus years of doing this stuff, I still refer to this pretty regularly. Most of them I know, most of them I could figure it out if I really think about it, but for the most part, I don't know. I just like to look at this. It's just easier. Okay, so this is in one of the files that I sent you. Okay, so please take a picture of this, copy it down to your notes, do something so you always have this. Okay, so you don't have to thumb through the book or all the files. You want to take this, post it somewhere where it's always in plain view. Okay, because we're going to be using it a lot. All right, so here we go. And I'm probably going to refer to it. So let me mark my page here. All right, so here we go. We're going to be verifying trig identities, okay? And the very first thing we're going to do is, let's start off with something light, okay? Here's my very first example. It is the sine theta times the cosine theta times the secant of theta. Okay, sine theta, cosine theta, secant theta. And we want to simplify this. Oops, sorry, I should have put A. Simplify, my bad, simplify. Okay, so before we verify anything, we want to learn how to simplify trig functions. So here's our very first thing. Now, most things you want as either sine or the cosine or the tangent, okay? But even with tangent, that can be changed, okay? Sine, cosine, if you see those guys like that, leave them alone, but look at this secant. Do you know another way I can write the secant? Now, if you look at your, here, I'll show you really quick. I mean, you should know this, okay? You should know that the secant is the reciprocal of the cosine, and vice versa. The cosine is the reciprocal of the secant. So basically, if you see a secant, you can turn it into 1 over the cosine, okay? Or write a fraction with cosine in the denominator. So watch what I'm going to do. I know sine is cool. I'm going to leave sine of theta, and cosine of theta, okay? But because secant is the reciprocal, and I know that turns into cosine in the denominator, I'm going to write a fraction like this and put cosine theta, and guess what? These cancel, and I'm left with sine of theta. Okay? So that's just a quick one that to get started, okay? That shouldn't have been too stressful. All right, let's try another example. Let's see if we could bump it up a little bit. How about the tangent of theta times the cosecant of theta divided by the secant of theta? Okay? All right, well, look, we have a fraction. So I'm just going to, my next step is just going to have a fraction in it. Okay, now watch what I do. I take the tangent and I say, okay, I know that a tangent has a sine and a cosine hiding in it. I know that the cosecant has a sine hiding in it, and I know that the secant has a cosine hiding in it. So that's all good news. I'm going to write all of this in terms of the sines and the cosines. So watch this. I'm going to take this tangent to start off with, and I know that that is the sine of theta divided by the cosine of theta. That's the tangent, okay? You should know that. If not, refer to that list, okay? All right, and then the cosecant, that's the reciprocal of the sine. So that means I'm going to take the sine, okay, here, watch, I'll show you again, just so you see this, okay. The cosecant is the same thing as the sine in the denominator. It's the reciprocal, right? Oh, and by the way, here's the tangent that I use. The tangent is the sine over the cosine, and incidentally, the cotangent is cosine over sine because they are reciprocals of each other. Okay, those are really, really important things to know, okay, or to refer to at least. Okay, and here we go. This cosecant, what did we say? That's the reciprocal of the sine, so that's 1 over the sine, so I'll put a sine of theta down here. This cosecant is the reciprocal of the cosine. So this is really 1 over the secant, so if that's the reciprocal, the cosine just goes in the numerator, the cosine of theta. There we go, and look at this. Sine cancels with sine, cosine with cosine, and we're left with 1. Look at that, it's simplified. Isn't that grand? All right, let's try another one. Do I have one that, here, let's try this one. Let's use something that you might not be aware of. Tangent of pi over 2 minus theta, okay, times the sine of theta. Okay, now before you get all crazy thinking like, oh God, I have to memorize this stuff, isn't this 90 degrees minus theta? Okay. All right, but let's look at our thing here. Okay, notice I have the tangent. Okay, the tangent of pi over 2 minus theta. Look what it equals. It equals the cotangent. Okay, and if you work that out on a right triangle, I guarantee you that'll make sense. Okay, for right now though, let's just use our formulas, because that's what I know most of you guys are going to be doing anyway, using the formulas. All right, if you do want to try to make sense of this, let me know. I will be more than happy, okay, to help you. All right, so this guy right here is the cotangent. So that's the cotangent of theta times the sine of theta. All right, and now keep in mind, I like seeing sines of thetas. I like seeing these too because I can use that to rewrite it as something with the sine, okay? Cotangent is the cosine of theta over the sine of theta, okay? And times the sine, right, sine of theta, over 1 if you want, okay? And look what happens. The sines cancel and we're left with cosine of theta. Okay, so these are all pretty simple simplifications, okay? Let's bump it up a little bit. You ready? Let's try something like this. All right, how about the cosecant, cosecant of theta. What should you be thinking? Cosecant of theta, I'm thinking reciprocal of sine, times the cotangent squared of theta, plus 1 over the sine of theta. All right. So now, a bunch of different ways you can go, okay? But I'm seeing this. I like that, but I'm not sure that I want to mess with this. There are a couple ways you can go here, okay? I'm gonna see if I can't turn these guys into sines and stuff, okay? So cosecant, that's 1 over, right? 1 over the sine of theta. 1 over the sine of theta, okay? Cotangent squared, cotangent squared, isn't that cosine theta over sine theta? Okay, but since it's cotangent squared, it's going to be cosine squared theta over sine squared theta. Okay, all right, and then you have plus 1 over sine of theta. Okay, now if you aren't sure about this, cotangent squared, think about it as cotangent of theta. That's cosine over sine. If you have cotangent squared, that's going to be cosine squared over sine squared theta. Okay. That's just how the squares work with those things. Okay, now watch. I'll show you. I'll take it to the next level. Watch this. Now look what I have here. I have 1 times cosine squared theta, so that's just cosine squared theta, over, look what I have. I have sine of theta times sine squared of theta. What do you think that equals? It's kind of like x times x squared. You get x cubed. So here we get sine cubed of theta. So I get sine cubed theta. Okay, then I have plus 1 over sine of theta. Now, I have a fraction. I'm adding them together. I need common denominators. So what do I need to multiply by here to get these guys to be the same? That's right, this is only sine theta, so I need to multiply by sine squared of theta. So I'm going to put sine squared theta, and watch what I get. Now I get cosine squared theta plus, this is sine squared theta now, over, now this is sine cubed theta. Sine cubed theta, I've got a common denominator. So sine cubed theta. And now watch this. Cosine squared plus sine squared. Let's look at this. This is a great Pythagorean identity. Cosine squared plus sine squared is 1. Okay, so I'm going to use that right now. That's 1. So this whole thing in the numerator just turns into 1 over sine cubed theta. Now, if I really want to simplify this so I don't have a fraction, what would that turn into? Flip it. Remember, sine is the reciprocal of the cosecant. So this is going to be the cosecant. Since it's sine cubed, it's going to be cosecant cubed theta. And that's that. All right, let's see if we can do another one. do I have another one that is even? Okay, yeah. How about this one? Let's try this. We have the cosine of pi over 2 minus theta, okay, minus 1, all divided by 1 plus the sine of negative theta. Oh, geez, this has got to be insane. All right, well, let's look at our identities and see what we can work out, okay? First off, okay, I see this guy right here, cosine of pi over 2 minus theta, okay? Think about a right triangle, okay? If we're not talking about theta, we're talking about 90 degrees minus that theta, that's the other angle, and what happens? It turns into the sine. Okay, if you don't know what I'm talking about, I don't blame you. I'm not really doing a very good job explaining it. But look, cosine of pi over 2 minus theta equals sine of theta. Okay, so that guy turns into sine of theta, okay? So here, I'll write that really quick. So this is the sine of theta minus 1, so minus 1 over 1. Now this is sine of negative theta. Now let's look over here. Let's see what sine of negative theta equals. Sine of negative theta is negative sine of theta. Okay? All right, so I'm going to plug that in. All right. So sine of negative theta is negative sine of theta. Okay? Now here's a fun trick. Okay? If you ever notice that up in the numerator you have like something minus something, and then in the denominator you have the same thing but they're flipped, you can memorize that. That's negative 1, okay? Here, watch this. I'll show you. Check this out. If I have 5 minus 1 over 1 minus 5, right? 5 minus 1 is 4. 1 minus 5 is negative 4. That equals negative 1. You could do that forever. What is 13 minus 2 over 2 minus 13? Watch this. 13 minus 2 is 11. 2 minus 13 is negative 11. Guess what? That's negative 1. So anytime you have this situation, something minus 1 or whatever, and then over the same thing but flipped, it equals negative 1. So negative 1. All right? All right, I'm going to pause and start a new video. I'll see you in a second.